Now we're going to try to put together all the information we had learned before about how to graph quadratic functions together in multiple examples. And in these examples, we're going to try to graph the functions by hand completely by determining a bunch of key features that we want to include on the graph. And they're listed through parts A and parts A through E. And for the first one, we want to determine the vertex and axis of symmetry. Then we want to find y-intercept and its mirror image across the axis of symmetry. Next, we want to use a quadratic formula to get the x-intercepts, so where the graph crosses the x-axis. And we want to find two other symmetrical points around the axis of symmetry to finally plot these points and draw the graph of the function through these points and by connecting these points through a smooth curve. With this information, we're going to start off just by doing part by part to find the important points first. So if we look at part A, for example, here's a function we can work with, and it's a quadratic function, so we are expecting a parabola. So the first thing we want to find is the vertex and axis of symmetry. And when we're doing this by hand, I like to find the axis of symmetry first, because this is going to be the information we can use for the x-coordinate of the vertex, because we know the axis of symmetry goes through vertex overall. So if we want to find the axis of symmetry, we are using the formula x equals negative b over 2a, and we can identify the b value over here is negative 4. It's important for us to not lose a negative sign. And then for 2a, it'll be 2 times 1, which simplifies out to be 2. And therefore, I know the axis of symmetry will be x equals 2. And we can kind of highlight or circle this information that'll be important for us. That's the axis of symmetry. And next, once we have the axis of symmetry, we can use the same formula to find the x-coordinate for the vertex. So that means we already know what's the x-coordinate for vertex. And to find the y-coordinate, I can just use f of 2, because 2 is the x-coordinate that we are given, or we found out. And if we find f of 2, we would get 2 squared minus 4 times 2 minus 5. And altogether, if we calculate it, we would get 4 minus 8, which would be negative 4, minus 5 will be negative 9. Therefore, we know the vertex in this case is going to be the point 2 comma negative 9. That's how we find the vertex over here. And once we have this information, we can move on to part B. In part B, we want to find the y-intercept first. And to find the y-intercept, we essentially want to let x be 0. And when x equals 0, we can find f of 0 is equal to just a constant term, which is negative 5, because everything else will turn into 0 as we plug 0 into x. All the other terms containing variable will end up being 0. And therefore, we know the y-intercept is 0, negative 5. That's the other point we want to definitely graph on our function. And then we want to find the mirror image across the axis of symmetry. This is something that you can use a little bit of scratch work to figure out as well if it helps. But if you think about what we want to get when we had the point 0, negative 5 on the graph, let's say if we just do it on the side a little bit, let's say 0, negative 5 is over here. And the axis of symmetry is x equals 2. So let's say this is the axis of symmetry, being x equals positive 2. And in order to find the mirror image, we want to use the fact that this point, the y-intercept, is equal distance to the axis of symmetry compared to its mirror image. And here we can see that distance between x equals 0 and x equals 2 will be 2 units. And same thing here, we would have 2 units being the distance on the other side. Therefore, for the x-coordinate for its mirror image, we would get the x value being 4. You can use 2 times 2 or 2 plus 2 to get x-coordinate equal to 4. because they're at the same height, the y-coordinate would stay the same. So we can say its mirror point is going to be 4, -5 as a result. And that's another point we want to eventually put on the graph. And then the next part, we want to use a quadratic formula to find the x-intercepts. And the reason we want to do this is when we want to find the x-intercepts, we know the function value is equal to 0, meaning y is equal to 0. Therefore, for x-intercepts, we want f of x to be 0, or x squared minus 4x minus 5 to be equal to 0. And this is a good place to kind of think about what is a quadratic formula and use that for our purpose. And just as a quick review, x is equal to negative b plus minus square root of b squared minus 4ac all over 2a. And with this information, we still want to apply the coefficients for the three terms being a, b, c, respectively, for our quadratic function in standard form. And with this information, we can get x is equal to negative b, which would be negative of -4. So I'm going to write down all the steps over here. Plus minus square root of b squared, which would be -4 squared, minus 4 times a, which is 1, times c, which is -5. And this is all over 2 times 1, because a is equal to 1. And with this, we can go ahead and simplify that. So we get x is equal to 4 plus minus square root. Inside the part, we would have -4 squared, which is 16, plus, because we have two negative signs next, so we would have a plus 20 over here, all over 2. And we can see x is equal to 4 plus minus square root of 36 all over 2. If you get that quickly, you can write square root of 36 to be just positive 6 overall. And I'm running out of space a little bit, so I'm going to just enter a few other rows. That way we have more room to work with. And here, if we simplify it, we get x is equal to 4 plus minus 6 all over 2. And as you simplify this, if we do 4 plus 6, we'll have 10 over 2, which is 5. Or if we had 4 minus 6, which would be -2 over 2, would be -1. So these are the two x-coordinates for our x-intercept. And for x-intercept, we know y is equal to 0, so we can say for conclusion, in order to get the x-intercept, we would have the points 5, 0 and -1, 0 being the key features we want to include in the graph. And lastly, we want to find two other symmetrical points around the axis of symmetry to finally plot the graph. And now in order to find the next point, you have a bit more freedom in terms of what points you want to work with. You can pick any x value that you would rather work with overall. So for example, I'm going to just let x be equal to 1 and see what happens. So if we had x equal to 1, then we can have the point f of 1 for y-coordinate. So if we want to plug 1 in, we would get 1 squared minus 4 minus 5 over here, which would be 1 minus 4 minus 5, and that's equal to -8. And therefore I know a point we would have is 1, -8. And its mirror image, again, we can use this to kind of help us. If we had 1, -8, it would have been, let's say, somewhere here. This graph is not to the scale, but we can get some rough ideas on where things are. And if we get 1, -8, and to find its mirror image, I want to go again equal distance, which would be 1 unit to the right of the axis of symmetry. And if I started with x equals 2, if I move 1 unit to the right, I would have the x-coordinate being 3 and -8 over here. So I would have 3, -8 being the mirror image. If you really want, you can also check your answers by plugging 3 into the function. If you did that, you would get 3 squared, which would be 9, minus 4 times 3, which would be minus 12. So 9 minus 12 would be negative 3, minus 5 would be negative 8, which is exactly what we did over here to get 3, negative 8. Alright, now that we have all the points over here, we can go ahead and try to plot all the points on the graph. And I'm going to move the note a little bit just so we can fit everything in one screen. The mirror point of this one we said would be 3, negative 8 based on our graph. So I'm going to highlight the points I'm planning to use, and just looking around with the values, I see none of the values are huge. So to scale my coordinate plane, I'm just going to go one at a time over here. I think I counted round. That would be 1, 2, 3, 4. Alright, and same thing with the other side. We can go ahead and label every other box. And you can choose different scales for the axis and y-axis if you want over here. So for the y-axis, we can just go by every box being 1, and I would have 2, 4, 6, 8, 10, similarly on the other side. And then for the x-axis, because all the numbers are relatively close to each other, if you want, you can make every other box be in 1 as well. Just know that that would mean your graph shape would change a little bit in terms of how wide or how narrow it is, because the scales are different on x and y axes. And now we can go ahead and plot the points. We have the vertex being 2, negative 9, so 2, negative 9 will be over here. Then the next point, y-intercept, is 0, negative 5, which would be here. Its mirror image would be 4, negative 5. We can see it is indeed equal distance away from the vertex we had. And then we had x-intercept, which is 5, 0, and negative 1, 0. Then the 2 points I just picked randomly would be 1, negative 8, and 3, negative 8. So these are all the points. And the next part is just to connect all the points through a smooth curve. I'm going to do my best to make it symmetrical looking and smooth looking. It's a little tricky to draw on a screen. Alright, so this should be our parabola graph roughly, and we went through all the key points that we had, and we can say this is a graph for f of x, and it could keep going on both ends over here.